Hey guys, today we're going to be talking about transformations, and more specifically we're going to be dealing with rotations. Remember that a transformation is a function that describes a change in the position, size, or shape of a figure. Rotations turn a figure around a given point, and in our case we're just going to use the origin on a graph. And when we think of a rotation, you could think of a clock. The hands on a clock spin clockwise. Okay, that's one definition we need to know. Clockwise is turning something to the right. Counterclockwise is like if a clock was going backwards, or that would be turning something to the left. Other definitions that we need to know will be a 90-degree turn, 180, 270, and a 360. 90 degrees is if this clock went from this 12 here, turning down to the 3. 180 is 2 turns, so that would be going from the 12 all the way down to the 6. 270 is 3 turns, so that would be going from the 12 all the way around to the 9. And then 360 is if the 12 turned all the way a full circle back to 12, and it goes back to its original position. So this time we're going to be taking this rectangle that we see here. Remember, this is the pre-image. It's before it's being moved. And we're going to be rotating it a few different ways. Now, unlike before, we are now going to take our rule and have that help us plot the points for our rotation. Before, we were able to reflect or to translate and then figure the rule out. But I think it's just a lot simpler if we just use the rule to find the points first, and then we'll plot them on the graph. So our first one says that we're going to rotate a rectangle 90 degrees clockwise or 270 degrees counterclockwise. The reason why I listed 2 different turns is because both would end up being in the same position. 90-degree clockwise would be taking this rectangle and going in order of a clock 1 turn. So it would be down here in this quadrant 3. Remember, this is quadrant 1, 2, 3, and 4. So if we rotate 90 degrees clockwise, that would be in quadrant 3. Now let's take the same pre-image, this rectangle, and imagine it being rotated 270 degrees or 3 turns counterclockwise, so 3 turns backwards, 1, 2, 3, and again it ends up in quadrant 3. So both end up being the same thing. Now we have this rule that says we're going to start with our point xy, and then look at what you notice about the letters. The letters flip-flop, so they change the position they're sitting in, so then it ends up being y first and then x. And then I'm also seeing this negative sign. Remember, we learned about the negative sign before. It's really not negative. Remember that it means the opposite. So we're going to flip-flop the x and y and take the opposite of whatever the x was. So let's try that here. This h, we're going to flip-flop it. So now the -2 is first and the 1 is second. And we're taking the opposite of whatever the x was. Well, x was 1, and now it's going to change to a -1. Okay, let's try it again. Let's flip-flop the numbers. So now it's -2, 6, and then we can't forget to take the opposite of the x. Well, the x was 6, and let's take the opposite. So now it's -6. Try it again. Flip-flop the order. So now it's -4 and then a 1. And we're taking the opposite of the x. Well, the x was 1. And so now it's -1. And then again, let's practice one last time. Flip-flop the order. So -4 is first and then the 6. And we're going to take the opposite of the x. Well, the x was 6. And now it's -6. So here's our new points, and we're going to plot this image. Okay, so let's go to -2, -1, 1 and 2, down 1, and this is point H prime. Alright, -2, -6, so over to -2, down to -6, and this is I prime. -4, -1, so over to -4, down 1, and this is now point J prime. And then -4, -6, down to -6, and this is K prime. And I'm going to take each point and we are going to connect the dots. And this is now our image, the shape after it has undergone a transformation. Alright, so this is called a 90-degree clockwise turn or a 270-degree counterclockwise. Now let's look at the next one. So the next one says to rotate the original pre-image 180 degrees. And if you notice, I didn't say counterclockwise, I didn't say clockwise, because it doesn't matter. 180 degrees, 2 turns would end up in the same quadrant no matter which direction you go. So let's say we go 2 turns clockwise. 1, 2. This is in quadrant 2 up here. Or if we go the other way, 1, 2, we're still in quadrant 2. So again, it doesn't matter whether it's counterclockwise or clockwise. So let's look at the rule. So for 180 degrees, XY, well, XY stays in the same order, but look, we're going to have to do the opposite of X and the opposite of Y. Okay, so let's write that out. So X and Y stay in the same order, 1, -2, but we're taking the opposite of both. So the opposite of +1 is now a -1, and the opposite of -2 is now +2. Okay, again, they stay in the same order, but we're going to take the opposite. So opposite of +6 is now -6. The opposite of -2 is now a +2. Again, they're going to go in the same order, but now we're taking the opposite of 1, which is -1, and the opposite of -4, which is +4. And let's do it one more time. Same order. Opposite of +6 is -6. Opposite of -4 is +4. And now we're going to take these points and plot them onto the graph. So the first one we're going to have is -1, 2. So go over to -1 up 2, and that was point H. So now this is H prime. Alright, point J is at -1, 4. So up to the 4, this is J prime. K is at -6 up 4, so -6 up to 4, and this is called K prime. And then we have I at -6, 2. And this is called I prime, and we're going to connect the dots to make our shape. Remember, after a shape has undergone a transformation, this is called the image. Remember, the starting shape is called the pre-image, and now this is our image. And this was a 180-degree rotation, either clockwise or counterclockwise. Alright, let's try the very last one. So the last one says to rotate the rectangle 270 degrees clockwise, or we could think of it as a 90-degree counterclockwise. So let's think about it. If we start at the pre-image and we go clockwise 270, remember 270 is 3 turns, so 1, 2, 3. We would end up here in quadrant 1. Or if we did 90 degrees counterclockwise, going backwards 1 turn, again, we're still in quadrant 1. So both are the same rule, as just 2 different ways of describing it. And so let's look at our rule. So again, the X and the Y flip-flop. They change order just like the first rotation that we did. They changed order here, they're changing order here. But this time, instead of taking the opposite of x, we're now taking the opposite of the y value. So let's practice. We're going to flip-flop the 1 and the 2, but we're going to take the opposite of the y. So y is -2, so we're taking the opposite and making it a +2, and then x stays the same, not the opposite, so it's just a +1. Okay, again, we're going to flip-flop the order, but this time the y goes to the opposite. So y was -2. It's now becoming a +2, and it's first. And then the 6 does not change, but it does go second instead of first this time. So again, we're changing the order, and the y is being changed to the opposite. So again, let's change the order. We have -4 is going to have to go first, but we're taking the opposite of y. So it's a +4, and then second is just +1. The 1 stays the same. And then again, flip-flop the order. The negative now becomes a +4, and it's first, and 6 is second. So again, we flip-flop the order. Y is first, x is second, and we had to take the opposite of the y value. So it went from a -4 to a +4. Now let's plot these new points. So we have h at 2, 1 and I at 2, 6. 2, 1 for h, 2, 6 for I, and these are called I prime and H prime. And then J and K, 4, 1, and 4, 6. So over 4 up 1, and over 4 up 6. And then we're going to connect the dots. And remember, when we connect the dots, this now becomes our image. Remember, the image is after the shape moves. Alright, let's discuss the size, the shape, and the orientation of what happens here. So let's look at the orientation first. Remember, orientation is what's happening to the shape's direction, which way is it facing. Now when we rotate, look, it's facing a different way each time. It's not always just facing side to side anymore. Now, even if you notice on the 180 degree, it's still side to side, but look, HJ turned to be on the right side when HJ originally started on the left side. So even the 180 degree turn is not facing the same direction. So orientation here changes. Now the size, when we rotate, the size doesn't change. It's still the same. It's a 2 by 1, 2, 3, 4, 5 rectangle. Each time it's staying a 2 by 5. Rotating or turning a shape or an object does not change the size, so it stays the same. And rotating these rectangles, they stayed rectangles, so the shape stays the same. The only thing for orientation, all of them change except for a 360 degree rotation. If we rotate something 360, that's making a full entire circle around. So if we took this pre-image and rotate it 360, 1, 2, 3, 4 turns, it's back in the same position. So just keep in mind 360-degree rotation does actually stay the same for the orientation. Alright guys, that's rotations. I think it's easier if we start with the rule on this one and use the rule to figure out the new points, and then we can graph our images. Don't forget that 90 degrees is 1 turn, 180 is 2 turns, 270 is 3 turns, and 360 is a full entire circle, 4 turns back to the original position. And then our other two definitions kind of go along with the clock. Going to the right is called clockwise, going to the left is called counterclockwise. Thank you guys for watching.